Hello everyone, my name is Bashar Deeb. I will be presenting the topic CASER, a cross-attention feature fusion for speech emotion recognition. Speech emotion recognition refers to the ability of machines to automatically identify and understand emotions conveyed in human speech. It has a wide range of applications across various domains. In human-computer interaction, it enables the development of more empathetic and responsive systems. For instance, virtual assistants and chatbots can utilize speech emotion recognition to adapt their responses based on the emotional state of the user, leading to more engaging and personalized interaction. In the field of mental health, SER or speech emotion recognition plays a crucial role in assessing and monitoring patients' emotional well-being. It can aid in diagnosing conditions such as depression, anxiety, and mood disorders by analyzing patterns in speech and detecting emotional indicators. And also, speech emotion recognition finds applications in market research and customer feedback analysis, because by analyzing the emotional content of customer service calls, product reviews, or social media interactions, businesses can gain a deeper understanding of customer sentiment, preferences, and satisfaction levels. Therefore, we introduce CASER, which is a feature fusion model between spectral features and self-supervised learning representations using cross-attention mechanism. The goal of our model is to enhance the accuracy of speech emotion recognition. The main contributions of the research is to augment spectral features of audio so they become tailored to SER, and to fuse the spectral features with self-supervised learning representations using cross-attention mechanism, and we then introduce a Python package for SER based on our model. Here you can see the architecture of the CASER model. We segment the utterance into sequences of fixed length each. These sequences are used as input to the wave-to-vec model, followed by a pre-processing model. Meanwhile, we extract the mel frequency substral coefficients and feed them into feature encoder module. Then we obtain fused representation by using the cross-attention fusion model. These representations can be used to classify the input utterance into one of the 4 emotional labels. In addition, we have the pipeline of our package. It consists of 2 submodules. The first is pre-processing, which performs scaling, normalization to audio, and extracting of the MFCC. And the second submodule is our CASER architecture model, which accepts the MFCC and the processed waveform to output an audio representation. This audio representation can be used either to predict the emotion label or in downstream tasks. For training, we used the IEMOCAP dataset, and we evaluated the model on the weighted accuracy and the unweighted accuracy. And here we state the results of evaluation compared to different baselines. We see that it achieves competitive metrics, although it only uses audio modality, which makes our model a lightweight compared to other models. Here we see a 10-fold cross-validation comparison where our model reached the highest value on both weighted and unweighted accuracy. Now I will demonstrate the work of the model. So we first need to download the repository. Then we need to navigate to the root folder to start. In order to use our package, we will go to the package folder and install the package using pip. The name of the package is CASER. After installation, we can use our package as follows. So here we have a Jupyter notebook. So first, we import the package, and then we define the emotion recognizer. After that, we can predict the emotion from microphone. So now I will run the cell, which will record the audio from the microphone in order to get the prediction. Here it got the prediction of neutral, and it also outputs the logits or the representation of the input. Also, if you have an audio file, you can import it into the model and extract the emotion label using predict emotion. So running the cell will give the prediction with the logits. That's all, and thank you for attention.